Vaisala Indigo, next generation industrial measurement. High-quality measurements are vital to ensuring energy efficiency, safety, and end product quality in all kinds of industrial processes and facilities. When it comes to choosing the right measurement instruments for your application, modularity, compatibility, robustness, reliability, low cost of ownership, and ease of maintenance are just some of the important factors to consider. Whatever your application, you should be able to focus on gathering accurate data and using it to keep your processes running smoothly, rather than spending valuable time on adjusting and maintaining your measurement instruments. The Vaisala Indigo family of next-generation instruments for industrial measurement includes intelligent, interchangeable, standalone measurement probes and optional transmitters, all configurable by Vaisala Insight PC software. With its modern, future-proof design, the Vaisala Indigo family heralds the dawn of a new era in industrial measurement technology. Indigo Smart Probes can measure multiple parameters. Their flexible design means you can adjust the setup to meet your current and future requirements. For example, if your facilities or processes change. While Indigo Smart Probes can operate as standalone devices, adding a transmitter makes setup and visualization of the data even easier. Indigo Smart Probes are easy to install and detach from the transmitter. The built-in display on the Indigo 200 series transmitter visualizes detailed data in a clear, understandable way, and the information and device settings can also be accessed remotely from a smartphone or other mobile device. With the Indigo 520 transmitter, you can connect two probes to the same transmitter to allow you to measure multiple parameters with a single device. The 500 series also includes built-in data logging capability, and with its highly durable metal enclosure and robust electronics, the 500 series can cope with even the harshest conditions. The Indigo 500 series has multiple system interface options, and it includes power over Ethernet, so you only need a single cable for installation. You can also connect a third-party measurement transducer via the analog input. Calculations of the measured variables can be done locally in the transmitter and then sent as an output to the automation or control system. Vaisala Insight PC software gives you quick and easy access to both calibration data and configuration setup for Indigo devices. The browser-based user interface makes probe setup, diagnostics, field calibration, and adjustment quick and easy. Take your industrial measurements to a whole new level with Vaisala's next-generation technology. Modular, accurate, and robust, as well as easy to install and maintain, and with a low total cost of ownership. Vaisala Indigo is the smart choice for all your current and future measurement needs. Ready to take your measurement equipment to the next level? Get started at vaisala.com/indigo.
In this video, we will concentrate on high humidity applications. Here I have Indigo 520 transmitter and HMP7 humidity and temperature probe. And this HMP7 is designed especially for high humidity applications. It has an internal heating element inside the probe head, and this can be used to prevent condensation. Indigo 520 supports two probes, and we will use this functionality, but at the moment you can see that this other probe cable is not connected, but we will come to that a little bit later. Let's first activate the heating functionality of this HMP7 probe. Condensation prevention can be activated by default by making the correct configuration in the ordering phase. The other option is to use a USB cable and a computer. So let's take this M12 connector off and connect the USB cable to the probe. And the Insight PC software detects the probe automatically, and we can see the measurement readings. What we want to do is to activate the condensation prevention, and this can be found from the configure device menu, and it's here. And let's save that. We are done. It's worth to mention that we will have warning here telling that supply voltage is too low for probe heating, and that's because we use a USB cable here, which is not able to provide enough voltage for this functionality. But let's fix that by putting the probe back into Indigo 520. Now that I have activated condensation prevention, we can see that we are no longer seeing the relative humidity value or temperature value, and the reason is that this sensor is now in elevated temperature, and it's no longer able to measure a representative temperature value from this surrounding environment. However, dew point temperature is still there in the display, and this is because dew point temperature is not temperature dependent, meaning that even if it's in elevated temperature, it can be still measured accurately. If this dew point temperature is what you want to measure, this setup is completely fine. But now if you need also a relative humidity or some other humidity parameter that needs the ambient temperature, we can use this functionality of two probe support that this Indigo 520 has. And for that I have TMP1 temperature probe, and let's connect that temperature probe to the transmitter like that. And now we have also a temperature reading which is coming from the probe number 2. To be able to calculate relative humidity based on the humidity level seen by this humidity probe and the temperature of the ambient, we have to activate the compensation. Compensation can be found from the menu and transmitter settings and compensation, and now it's activated, and we can see that the compensation calculation started and relative humidity reading is on the display. Now we have activated the condensation prevention and made all the software adjustments for the Indigo 520 transmitter to calculate the relative humidity. The next thing is to consider the mechanical assembly. And now the idea is to get this temperature probe in a representative position, and also this humidity probe close by, not too close that it would affect on the ambient temperature reading. And there are different ways to solve this mounting, but in this video I will demonstrate how to use HMT 330 WPA warmth probe accessory set. The idea of this accessory is that the humidity probe is on top and the temperature probe is below it. So let's start. Okay, assembly is now ready, and Now the last thing is to take care that we have proper insulation if our process is hot, so that there is no temperature leak when we put this assembly in our process. Thanks for watching.
Imagine un mundo industrializado con equipos de medición imprecisos. Eso provocaría malas decisiones y resultados no deseados. Afortunadamente, las industrias ya apuestan por el desarrollo sustentable, resolviendo los desafíos relacionados con el rápido crecimiento de la población y la urbanización en nuestro ecosistema compartido. Con 80 años de experiencia, Vaisala respalda las observaciones a favor de un mundo mejor con dispositivos de medición confiables y precisos. Vaisala lleva décadas creando tecnologías de medición líderes. Ahora Vaisala mejora y es aún más ingeniosa con una familia de productos nuevos y robustos. La familia Vaisala Índigo es la elección premium para medir parámetros en instalaciones, procesos o equipos industriales, como por ejemplo la humedad, la temperatura, el dióxido de carbono y el peróxido de hidrógeno vaporizado. La familia Índigo incluye sondas de medición inteligentes e intercambiables, dispositivos host opcionales y el software Vaisala Insight para PC. Las sondas contienen reconocidas tecnologías de sensores, como HumiCap, CarboCap y PeroxCap, que Vaisala desarrolla continuamente para garantizar un rendimiento superior en los procesos más modernos. La inteligencia de la medición en las sondas indica que son fáciles de retirar, son compatibles con los dispositivos host de Índigo y también se pueden integrar a otros sistemas. Usar Vaisala Índigo es un movimiento estratégico hacia una mejor conveniencia, compatibilidad y precisión continua.
The Vaisala brand name has become synonymous with best-in-class quality and reliability.
Vaisala has 3 levels of products available for most applications. High reliability and stability of measurement is a standard feature for all of these. The second levels of products increase the measurement accuracy even further and adds the traceable calibration certificates. The third level adds environmental robustness, which is needed in industrial applications.
To achieve cost efficiency without compromising quality, Vaisala offers instruments that fall under 3 different levels of products. For instance, the 80 series is a perfect choice for customers who want to pay a competitive price but still benefit from the superior quality and customer service that Vaisala delivers.
The GMW 80 gives you all of the measurement accuracy and stability you expect in a more affordable package. Due to the CarboCap CO2 measurement technology with the internal measurement reference, it works properly also in spaces occupied 24/7. An additional benefit is also that you can immediately verify proper operation after power on.
In the different levels, customers can expect instruments with a wider variety of measurements, NIST traceable certification, and features like calculated parameters and fast in-field recalibrations.
We have invested years, even decades, developing our world-class sensors. All of our sensors are made from scratch in our state-of-the-art clean rooms in Helsinki, Finland. Vaisala sensors will not let you down.
For over 75 years, Vaisala has led the industry and been trusted by customers at every level. Whether used in a warehouse, at an airport, or in Paris Louvre Museum protecting the Mona Lisa with our 330 series transmitter, Vaisala instruments deliver uncompromising quality to all.
Hello, my name is Lars Stormbom and I work for Vaisala as a product manager. Today I want to talk to you about the new HMD62 humidity transmitter. It's still the same familiar footprint, but the technology inside is completely renewed. We have replaced the latest generation industrial HumiCap sensor and this gives you even better stability and a possibility to get even higher measurement accuracy for those applications where you need really tight humidity control. What we also have done is we have included the ability here to get the calculated humidity parameters directly out of the box. We also know it's really important for you that you can easily configure these devices on the field. So if you want to select dew point instead of relative humidity outputs, you simply flick a switch on the circuit board, and that's all you need to do. So in this way you can really easily get dew point, enthalpy, and wet bulb temperature, for instance. We also know that you need to service your devices and make field adjustments periodically. So we have given you several ways to do this quite easily. One way is to use the Vaisala HM70 handheld instrument, and if you connect that to this device, you can make a simple one-point adjustment by just pressing a button. We have also retained the familiar trimmers, so you can make offset adjustments really easily, both for humidity and temperature outputs. So, in this way, we have wanted to make your life easier, both when installing and servicing the device. If you want to know more about the new HMD62, visit our website.
This is the HMD62, our next generation humidity and temperature transmitter. For us, innovation isn't just about new ideas, but a new perspective. It enables us to see things differently and discover what really matters to our customers. But why should you choose the HMD62? Because we think it will change the way you see things.
This is our latest humidity and temperature transmitter, the HMD60. Before we released it, we put it through a series of environment and mechanical tests.
Hello, my name is Vicky. I'm a senior hardware test engineer at Vaisala. We want to learn and observe that how well the device can perform in different temperatures. So we test our device at +80 because we want to see that it can operate and measure as we have promised. So we also test at +90, and we want to see that at which point it starts to break and where it starts to show some weak points. For example, when we test in a cold environment at -40, we first put the device there, turn off, and let it stay there for 1 hour. And then after that, we turn on to make sure that it can do the cold start. But we also test beyond what we promised. In -50, the measurements are logged, and we observe that during the whole time it measures, and there's no time where it freezes down or suddenly turns off. We test vibration test because we want to observe and study that how well the device can perform and operate in these conditions. So we also perform drop test for the device with the transportation box. For example, we drop it from 1 meter 13 times, but we also drop it up higher because you never know, during the transportation it can go beyond. Hardware testing is also important feedback to our other members, such as electronics engineer or mechanical engineers, because during the design phase they have options to think that which electronic components that they want to choose or what kind of mechanical design they want to use until we get a device that is robust, that is reliable, and it performs accurately.
Some may call this extreme testing, but for us, it is an opportunity to test beyond our promise. Because we believe that it is key to delivering what you expect of us.